Looks at an application of exponential functions, and we look at the world of finance. So when you invest money, a lot of times the financial institution that you lend your money to or invest your money in will pay you interest. There's two ways that they can pay you interest: simple interest and compound interest. So with simple interest, usually you're looking at a short-term investment, 1 year or less, or a long-term investment where you're collecting just the interest each year and you're using that interest for whatever purpose you have. So that could be a fairly large sum of money. Actually, the scholarships that we have at the school that are handed out at graduation would be an example of this, because what is done is the amount of money paid out is equivalent to the interest that is earned in the given period of time. So some years are better than others depending what the current market interest rate is on those particular accounts. So if I have $500 and the interest that I earn is 6% a year, how much money would I earn in interest in 1 year? How would I calculate that? What did you get, Rachel?
I got $30.
And how did you get that?
0.06 times 500.
So how much do you think you would earn in half a year?
$15.
$15, because I'd multiply that by half. Okay? What about in a month? What would I do then?
Divide the 30 by 12.
Divide by 12. And if I told you that the division button was broken on my calculator and I couldn't divide by 12, what could I multiply it by? 112. Good. And so how much interest do I earn in 1 month?
$2.50.
So suppose that R is my interest rate expressed as a decimal, and P dollars, is the initial investment. So to calculate the amount of interest that I would earn in 1 year is I would take that P dollars, which was my 500, and I multiply it by my interest rate. So how much would I earn in half of a year? What would I do?
1 over half times 50.
Okay. Times. And T years. So it could be 5 years, it could be 8 years, it could be 18 months. So T years. It would be P times R times T. And that becomes our simple interest formula. So just a couple of quick examples. Millie invests $2,350 at 7% per year for 6 months. What is the simple interest on her investment after 6 months? So what would I multiply together? So 2,350 times what?
0.07.
And then the time would be 1 over half, because it's half of the year. So the time is always expressed in years. What did you get, Addison?
$82.25.
Good. So then what's the value of Millie's investment? In other words, how much money does she have altogether? So what are you calculating, Jessica?
I just added the $82.25 to the original investment.
And what did you get?
$2,432.25.
Okay. That's simple interest. Compound interest is a little bit more complex. interest, the principal at the beginning of the second year is the same as the principal in the first year. So at the beginning of the second year, I would only be investing or earning interest off that $23.50. I would not earn interest off the $24.32. In compound interest, what we do is we reinvest the interest. So in year 2, I would earn interest off my new value. So the value or the principal changes after each period or each term of the investment. That's the difference between simple and compound. In compound interest, your interest earns interest. So you end up gaining more money. So there's an investigation that we can look at that shows us the difference between simple and compound. We look at savings bonds. There's 2 types of savings bonds I can get. I can get a regular savings bond that gives me 9% PA, which stands for per annum, and annum is a year. Or I can have a compound savings bond, which pays me 9% per annum, compounded annually. So if I look at the simple interest side, 9% of $5,000 is $450. That's how much interest I earn each year. So the value at the end of the first year is $54.50. In the second year, so this is taking $5,000 and adding $450. That's how I get the $54.50. At the end of the second year, I add another $450. Now I've got $5,900. So in the third year, I would add $450 to get $63.50. In the fourth year, add another $450, and I'm now at $6,800. So take a moment and complete the next 4 years. So at the end of 8 years, I would have $8,600. Now with the compound interest. In the first year, I would have $5,000 plus the interest. And the interest I get by going 5,000 times 0.09. If I look at this from an algebraic standpoint, I've got a common factor of 5,000. So I factor the 5,000 out, and that leaves me with 1 plus 0.09. So this becomes 5,000 times 1.09. This gives me the value of the bond at the end of the first year, which is my $54.50. Then in the second year, what I do is I take the value or the principal at the end of the first, which was my 5,000 times 1.09, and I multiply it, or sorry, I would add that to the interest. The interest that I would earn is that principal amount, the 5,000 times 1.09, times the interest for that year of 0.09, or my 9%. Again, from an algebraic standpoint, 5,000 and 1.09 are common factors. So if I factor it out, I'm left with 1 in the first term because I'm dividing by itself. And in the second term, I'm left with the 0.09. So when I add those together, I get another 1.09. And now I have 5,000 times 1.09 squared. So now I look at year 3. In year 3, I take the principal amount that I have now, which is from the end of the second year, which is this amount. This 5,000 times 1.09 squared. Do you want to pause that for a second, perhaps? Listen to all of them. So when I go to calculate the interest, I calculate the interest by multiplying 9% by this amount. So this amount being the 5,000 times 1.09 squared times the 9% as a decimal. Again, from an algebraic standpoint, I have common factors. And the common factors being the 5,000 times 1.09 squared, which leaves me with 1 in the first term and 0.09 in the second term. Add those together, and I've got 1.09 squared, and then another 1.09 1.09. Bases are the same, so I can add the exponents, and I get 5,000 times 1.09 cubed. So then if we look at the chart on the following page, this helps us to calculate what the value of the bond would be at the end of year 2, year 3, year 4, etc. So in year 2, I'm going to show you something you can do on your calculator. When we're dealing with money on our calculator, if you go to mode and you change the float to 2, it will change your settings so that everything gets rounded to 2 decimal places. So it's great when you're dealing with financial questions because it'll round to 2 decimal places for you. So if I put in my first amount, 5,000 times 1.09, there's my $5,450. If I do that for the end of the second year, it's now 1.09 squared. So at the end of the second year, I'm at $5,940.50. This is actually $40 more than what I had under the simple interest. Because if you look at that simple interest chart, we were at $5,900. Then if I look at year 3, it would be 5,000 times 1.09 to the power of 3. And I get $6,475.15. So I'm going to give you a couple of minutes, and again, I want you to finish that chart off. So at the end of the 8 years, you've got $9,962.81. This is actually $1,300 more than what you had under the simple interest. And all it was just taking a different plan. So at the end of n years, the value of your bond would be 5,000 times 1.09 to the power of n. Okay? To move this along, in general, if we created a formula, we said A is the final amount. It's the value. So this is my A amount. P is my principal, so it is still the same P as in my simple interest. It's what I started off with. R is my rate of interest, or the annual interest rate, and N is the number of years. So I get this formula where A equals P times, and we took the 1 and added it to the R, so 1 plus R to the power of N. So the next thing to show is if we graph these two charts. So if we take the first chart, the simple interest chart, and the compound interest chart. So if you have two different colors, or if you don't, use X's for one and circles for the other, just so you can distinguish. But take a moment and plot the points from the two charts as best as you can. So what you should notice is that your graph in simple interest is linear. It gets this straight line, and it's going to grow by the same amount every single year. Whereas your compound interest is growing more quickly. It starts off the same, but then it's starting to show this rise. And because its growth is like almost gaining, it's exponentially. So it becomes an exponential equation. So our exponential equations from the last chapter were y equals a times b to the power of n. But because we're dealing with something that's interest related, our y's, our a's, and our b's can actually have specific values. Our y is the amount of the investment. Our a is that principal amount. And our b is that 1 plus the interest rate. It's that growth factor to the power of n. So if if you flip the page, what you see is the compound interest formula, which we've already written out now twice. The only difference is in the terminology surrounding the I and the N. The I represents interest rate per compounding period. Okay, not per year, it's per compounding period. Because when I start compounding, I can compound things yearly, semi-annually, which would be twice a year. I can do this quarterly, I can do this monthly, or I can even have a daily interest fund. So if I'm compounding something daily, it's that annual interest rate is being divided by 365. Then N becomes the number of compounding periods. So if I'm compounding something daily, in a single year, I have 365 compounding periods. If I'm compounding something quarterly, how many times a year am I compounding it?
4 times a year.
4 times a year. So that means at the end of each quarter, I get my interest and it gets added on, and so the next quarter I earn that much more. And then the next quarter I take that new value each time. Okay, let's look at this chart and see where we can get on getting this chart done, because it really shows the difference between the different compounding periods. So in this question we have $1,000. We're investing it for 5 years, and the annual interest rate is 6%. So we're going to look at the table of values just to see under which circumstances can we gain more money. Okay? So if we compound something annually, how many times per year is that? Once. So in a total of 5 years, how many compounding periods would we have? 5. And the interest rate every compounding period, because it's 6% per 1 year, is going to stay at 6%. So now if I put that into my formula, I've got 1,000 times 1.06 to the power of 5, which gives me an amount of $1,338.62. Or sorry, not 62.23. Not even sure how I got 62 out of that. Semi-annually means how many times per year? Twice. So in 5 years, how many periods would that be? 10. And what would be my interest per compounding period?
Still 0.06.
But I'd have to divide it by 2 because it's twice a year. So I take my 0.06, divide it by 2, and I get 3% per compounding period. So now my formula becomes 1,000 times 1.03 to the power of 10. And I get $1,343.92. So what I want you guys to do is I want you to do the next 2 rows. Let's look at these 2 rows. Quarterly has how many compounding periods per year? 4. So in 5 years, how many compounding? 20. And then what is the interest rate per compounding period?
0.015.
Right, because I take the 6%, divide it by 4. So then my formula becomes 1,000 times 1.015 to the power of 20, which gives me $1,346.86. And then finally, monthly, how many periods per year?
12.
So how many total? 60, because it would be 12 times 5. And my interest rate?
0.005.
So then my formula becomes 1,000 times 1.005 to the power of 60. And how much money do I have at the end of 5 years?
$1,348.85.
Right. So the purpose of this
Mrs.
chart,
Goodall, line 2, please. Mrs. Goodall, line 2.
the purpose of the chart is just to outline how compounding periods can actually earn you more money over time. Okay, $7,000 invested in a 6-year GIC, compounded quarterly at a rate of 5% per annum. Determine the value of the investment at the end of the term. So if I write down all of the variables from my formula, that sometimes that helps me be able to set it up and to figure out what it is that I'm looking for. So what pieces of information do I know so far?
P is 7,000.
Okay,
5% divided by 4.
okay. Which then is what, 0.0125?
Yeah.
And then what's n?
24.
And how do I get the 24?
Do 6 years times 4 for the quarter.
So then the value at the end of the term becomes 7,000 times 1.0125 to the power of 24, which gives me a value of how much?
$9,431.46.
Good. So the next 3 questions basically are using this formula. So this formula is not on your formula sheet, but it is derived from our exponential formula. It's just A is our principal amount, and B is that growth rate. It's what the interest rate is growing by, or the investment is growing by. So Christine invests $2,500 for 4 years, compounded semi-annually, and receives $843.26 interest. What is the annual rate of interest? So what am I looking for? Okay, this is what I'm looking for. So that means that I need to know the other 3 values. So let's start with n. How many compounding periods do I have?
8.
And how did you get 8?
For 4 years and then twice a year.
Okay, compounded semi-annually, so twice a year, 4 years. What's my principal amount? What did I start off with?
2,500.
2,500. And what do I end up with?
$3,343.26.
And how did you get that amount?
You add the interest received to the amount you had at the beginning.
Because the amount is the interest plus that principal. So when I put this into the calculator, 3343 would equal 2,500 times 1 plus I to the power of 8. So how would I solve this?
Divide by 2,500 on both sides.
Okay, so 3343, 26 divided by 2,500 becomes 1 plus I to the power of 8. Well, how do I deal with that power of 8? I wouldn't want to distribute it into the brackets because this would be like m plus n to the power of 8. That means multiplying it by itself 8 times. So I wouldn't want to expand it that way. But what could I do? What if I had it as squared? What would you do? So if I square root it to get rid of a squared, what can I do to get rid of the 8?
8 rooted.
I could 8 root it. The other thing that I could do too, what can I multiply by 8 to get to 1? 1/8. So I could raise it to the power of 1/8, and I could raise this side to the power of 1/8. The 8th root or to the power of 1/8, either one would work. It just depends what you find easier to put into the calculator. So if I pull my calculator out to put that in, there. So I have my bracket, $3,343.26 divided by 2,500, and then I raise that to the power of 1 divided by 8. So I would use brackets for that exponent. And I get probably not 1.04, because I'm still in the wrong mode. There we go. So I get 1.037000028. So 1.03700. So how do I get I?
Subtract 1.
Subtract 1. So then I equals 0.03700. This is the interest rate per period. So to get the annual interest rate, what would I have to do? So this is the interest rate every 6 months. So how do I figure it out for a year?
Times it by 2.
Times it by 2. So if I multiply it by 2, what would I get? I get 0.074, which is what has a percentage?
7.4%.
7.4%. Okay, so remember, I and N refer to per period. N is the number of compounding periods. I is the interest rate per compounding period. So if the interest is compounded monthly, I is going to be the interest rate per month. So then when I want the annual interest rate, I multiply it by 12. Okay? So if we look at class example number 5. Barbara wants to invest $8,000 in an account which pays interest of 6% per annum compounded monthly. How long would it take in years and months for her investment to double in value? So what information do I know? What variables can I find?
He is 8,000.
Okay.
Well, your A wouldn't have to be 16,000 because that's be double.
Right?
Would you take your 6% and divide it by 12?
Why 12?
Because it's monthly.
Right.
So when you get 0.005.
Okay, so, and then N is what I'm trying to find. So I get 16,000 equals 8,000 times 1.0005 to the power of N. So what would I do first?
Divide by 8,000 on each side.
Okay, and when I divide by 8,000, what do I get? Or what do I get on the left-hand side?
2.
2. So how do I deal with this exponent?
Turn it into a log.
Good job. Turn it into a log. So this would become N equals, what's the base of my log?
Log base 1.005.
And my argument is 2. So then how do I put that into the calculator?
Log 2 divided by log 1.005.
What'd you get, Rachel?
138.975.
So what would I round that to? 100, is it 138 or 139?
139.
Okay, and this is 139 periods. convert that into years and months. Because, each period is how long? It's a month. So this is 139 months that I'm calculating. How many years are there in 139 months? So I get 11 years, and how many months are left over? How'd you get the 7 months?
I did 11 times 12 is 132. And then plus 7 is 139.
Yeah. So I've got 139 divided by 12 gives me my 11.583 repeating. There's two ways that I could do this. I could do this the way that Rachel was talking, which is I go 11 times 12 is 132 and subtract from 139. Or if I subtract by 11 and then multiply that answer by 12, there's my 7 months. So that's another way of doing it. We'll save the last question for Thursday. Last question. The interest formula, or the compound interest formula, can also be used in situations when you were borrowing money and you were paying interest. So when you borrow money from the bank and you pay that money back to the bank is going to want more than what they lent you. They're going to want a service fee in the form of interest. If repayments are made on a regular basis during the period of the loan, we can't use this formula. This formula assumes that you're paying the total sum back at the end of the loan period. If you're making monthly payments, it's actually a completely different formula that's used. So Andrea borrows $7,500 from her parents to buy a new car, and her parents are charging her interest at a rate of 4%. PA stands for per annum compounded quarterly. When she pays off the loan, she has to pay $785 interest. So the question is, what was the length of the loan? So if I look at my formula, A equals P times 1 plus I to the power of n, and then I look at my variables, what variables do I have amounts for? So what's one amount that you can tell me?
7,500 is your A, is it?
Is 7,500 A or P? Why P?
It's the amount that you started with.
The amount that I started with, okay?
And
So
then
what do I end off with?
8,285.
And how did you get that amount?
7,500 plus the 785 interest.
Okay. What else do I know?
I is 4% divided by 4.
Okay. Which then becomes,
0.01.
and then n is what I'm trying to calculate. So I have 8285 equals 7,500 times 1.01 to the power of n. So how do I work to get n by itself?
Divide both sides by 7,500.
Okay, so now I have 8285 divided by 7,500 equals 1.01 to the power of n. Then what would I do?
Do you have to turn them both into logs?
I have to go into logs. So do you want to take the log of both sides, or do you want to just write it into a log?
Write it into
So then n would equal, what's the base of my log?
1.01.
And then I have the 82, 85. The 82 or 83, sorry, 83, 85. Erase that. That was my mistake. 83, 85.
82.
No, it's 82. Some places I can add, some places I can't. 82, 85 divided by 7,500. So how do I put this into the calculator? Because my calculator can only do base 10 for logs. Well, except for Jessica giggling over there. I can do it this way.
And go log 8285 over 7,500 divided by log. Well, that's the log.
Okay, so then what does n equal? Okay, and 10 what?
Compound periods?
And what are my compounding periods?
Quarterly.
Quarterly. So this becomes 10 quarters. So if I convert quarters into years, how many years would I have?
2 years and 2 months.
Not 2 years and 2 months.
2 years and 2.
Two of those quarter periods, which would be 6 months. So 2.5 years. Because I could take the 10 and divide it by 4. And I think the questions I gave you on Tuesday were questions 1, 3, 5, 7.